Good morning, folks. We're going to try to get our world modeling stuff working today. I believe where we left off. This might need to be rebooted. One sec. This dropped CUDA. 1 second there. Let me reboot this container, and then we'll show the current result, which is that we have a world model that trains above random perf. That's pretty much it. Okay, so here it is. So the question is how we effectively take this from this like super unstable thing to something that we can actually use effectively. You know, I kind of just want to spend a little time sort of thinking through all the different things here. Welcome something. Yeah, let's just do this. Okay. So what have we have done? Like we have done, I think we have the recurrent state space model, right? And then we have like the losses. And then we have like directional correctness. But it's like unstable and like generally not that good. Hey Tim, shout out to your barber. It's the same place I've been going since I was an undergrad. Little Vietnamese shop. They're always super quick, never giving me a bad haircut. We trust the Vietnamese in matters of food and in matters of barbering. I was just saying yesterday, I wish we could just replace McDonald's with a good pho chain. It would be a market improvement for the country. Okay, things we haven't done right. Scale. Tuning. All the tricks. And also the compute scale as well, right? Can you show the previous results of your code? We have a thing that does substantially better than random consistently on cartpole. This is by no means a good result. It is at most a directionally correct result. but it is at least a starting point. Oh yeah, also replay. You know, the replay might actually be important here, right? Because, like, the replay slows down the pace at which you're getting new data. Actually, world predicting. Yeah, there's a reconstruction loss. It's not pixels, right? We're not training on pixels, but there is a reconstruction loss. I mean, ultimately, right, there are only two sources of error. Your RL is bad or your world model is bad, right? And our RL is usually pretty good. If I were to, like, grade these on how important I think they are, right? Scale, you really shouldn't need scale for cart pull. This is like a C. Tuning. Tuning actually usually makes a big difference, so there shouldn't be anything here different, so that's a B. The tricks. Let me see what specific tricks they have. Simlog. Advantage norm. The only thing possible is maybe the KL balance, but we're not seeing that loss. So other than KL, this is like a C. Okay. And then there's also like maybe like I have like not done sampling or gradients correctly. Compute scaling. I think this is maybe like a B. It might just fundamentally take a little bit more compute with this setup. The replay is actually the only thing that I think is like an A. Like in the sense of maybe like how likely these things are to matter. So I think what we do, we implement a replay buffer. We scale a little bit compute and tuning, and we see if we can get cart pull stable, and we go from there. Wouldn't on-pol world model risk biasing heavily to current policy and mess the world model up? Can that happen? I don't think that can happen, Tim, because the world model is not trained on hallucinated data. The world model is trained on the current data. So I don't really think you can mess the world model up. I think it's pretty hard to mess the world model up with the agent. I think more so you mess up the agent with the world model being behind. I could be wrong, but that's what I would guess. We also have this replay scaling here. And the steps. At the very least, this is way better scaling than on Paul, right? Wouldn't it only see current policy states? The world model, yes, the world model sees states from the current policy, like actually actually enacted on the environment, though. So yes, training the world model is dependent on the policy. You'd have to collapse the policy to like start feeding the world model bad data, which I suppose you can get. So maybe. Yeah. I think we try replay buffer first. I'm gonna put this on the side. We're gonna try replay buffer. The easiest way to do this then we'll just do like, was it? Uh, just do like, yeah, like this, divide by 16. Segments, horizon. You don't need this. Okay, so next thing I need, right? Do you have full buffer? Oh, you need some indices, don't you? Okay, so after eval, just do full seg min. Yeah, so like this. Now we know if the buffer's getting filled up. And then this is going to be, the index is going to go up to full segments. Okay. You're going to do a certain number of mini batches. Like this, right? And then at the end, we're going to shift replay. Okay, which is going to be so like max hold max equals oh, dot. And then what we do is we do self.observations. And we'll just do equals. Let me see if this works. I believe this does. I wish I could disable this multi-line complete thing. This. Okay, so what this should do is this should just keep the most recent segments. Or to these. Maybe need to be like this. Okay. So So this, it fails on the second time through. Let's see what I've messed up here. And then this will be like a simple replay buffer. Actually, this is a good question for somebody that I don't know. Is there actually like a much more copy efficient way to implement a ring buffer that makes sense in this context? There probably is, right? Oh yeah, you totally can just, well, there's a good way to implement a ring buffer, but as soon as I do prioritized replay anyways, then there's no efficient way to do it. Actually, does anybody know, like, there's no efficient way to do a ring buffer when you're doing, like, prioritized replay, right? Because you're just, like, grabbing arbitrary samples and overwriting them. Wait, refer to the same address in memory. Wait, why is that a problem that they refer to the same address in memory? What's this say? Let's ask Grok. This is like a weird, obscure thing. I would think that you should be able to do it. Oh yeah, this is not mine. Don't worry, this is not my account. I was seeing if I could get a username. Oh, it is because it's a mem copy, right? I answered my own question. It's because it's one mem copy. So apparently, you should actually be able to make that work, to be fair. Well, that's, like, that's substantially more stable. It's not perfect, but that's way better than before, right? Literally just from having a buffer. Okay, and then if I do... Let me just make sure I'm testing the thing I think I am. Oops. 1 second, be right back. So we're going to try a little bit of compute scaling. Wait, I wanted to check one thing first. Yeah, so this is the full world model. Four update epochs. Still a little bit unstable. Yeah, still quite unstable, in fact. It's like massively better though, right? We have to just fix the instability now. It's no longer bad, it's just unstable. Yeah, so if this thing stops just collapsing itself every 2 seconds, it'll be good. Let's just, like, look at the parameters that they have in the paper. We're gonna get this shit to work today. I'm gonna have this working, at least as, like, a decent bit, and then we're gonna have, I'm gonna get it cleaned up as best I can, and then I'm gonna have myself a nice dinner, and that's gonna be a good Saturday's worth of work. Of course, it's gonna take quite a bit of fiddling. I want to get not stuck on, like, silly things all day. I think that we got a pretty clear-cut plan now. Okay, so experience replay. Uniform replay buffer with an online queue. Each mini batch is formed first from non-overlapping online trajectories and then filled up uniformly with uniformly sampled trajectories from the replay buffer. Latent states into the replay buffer during data collection. To initialize the world model on replayed trajectories. What? That seems stupid. Write the fresh latent states of the rollup buffer back into it. We found, experience replay to improve the performance of Dreamer. We opt for okay. Fresh latent states. Does anybody understand why you would do this? This part seems weird. We parameterize the amount of training via the replay ratio. The fraction of time steps trained on per time step collected of the environment. Yes, without action repeat. Okay. So yeah, so this is sample reuse. Dividing the replay ratio by the time steps in a mini batch yields the ratio of gradient steps to m steps. A replay ratio of 32 on Atari with action repeat form batch 14. One gradient step, 328. So we don't really care about gradient steps per m steps as much, though it's useful to keep in mind, perhaps. Adaptive gradient clipping. This we should at least try. That one actually seems like... That one actually seems like... What the heck was that? Alright. We don't care about this. 3-layer MLP, 1-layer GRU. They have very high replay ratios and everything. Minecraft is actually lower. B Suite, they have super high. And Atari 100K is 2 to 3 hours of GPU compute. Bro, that's insane. For 100K. Oh, because that's including skip. Okay. Massive models. Alright, so these robustness techniques, which we know are bullshit. This is whatever. Adaptive clip, okay. Yeah, so that's fine. Larger capacity online queue, storing and updating latent states. Larger capacity online queue, storing and updating latent states. That's weird. Replay capacity of 5 million, right? 26? Yeah, 5 million. Wait, batch size is 16 x 64. So what is that? That is that 512? No, that's 1024, right? Yeah, this is so 1024. So this is then actually, if you go by the ratios here, right? This is yeah, so this is basically what this is saying to me is that the replay is actually changing quite slowly here, right? Because this is 16 times 64, 1024 samples in a batch. So how do we make this efficient with our setup? I think we just do... If I just do... Well, we can't go that crazy, can we? I don't want to go that crazy. Let's do like 256. 256 M's. The batch size of... But that's 4096 batch size, right? That'll actually happen automatically. And then instead of doing update epochs, we just do... Okay, so there's instability, but like, I mean, that's in a million steps, not even, right? There's definitely instability. I wonder if it does eventually stabilize or not. See, like that type of thing there, definitely getting weird spikes. But the potential's definitely here. I'm actually kind of curious if I just shift this to breakout real quick. Does it do anything? Oh, you know what? It's not going to. We have to... Fine. Hey, Kevin. How's it going? You'll actually probably be kind of interested in this stuff here. This seems to be, at least so far, the most promising thing. I need to figure out how to make it stable. But this actually is fairly promising. Where's my watch? Why is it this unstable? What's the idea? We're basically adapting world model stuff from Dreamer, stripping out the bullshit parts and getting it into an actually efficient implementation with Puffer. And we're gonna see whether this actually, we're gonna essentially try to bridge the gap between data efficient RL and compute efficient RL in one implementation. And why is it so unstable? That's the big question. We added the replay buffer, we added a little bit of compute. And now it's very good, but it's very unstable in a sense, right? That like it completely crashes out. Dynamics loss, representation loss, reconstruction loss. Not like learning rate or something stupid either, right? Like I could technically mess with that, but I really don't think that's what it is. Is there anything more fundamental here? I'm a bit confused as to how... Supposed to clip these losses at 1, right? I don't understand how you could possibly be clipping these losses at 1, though. Loss and representation losses. Well, I guess at least now that we know we have it somewhat correct, we need to, like, go through the reference a little bit. Is there actually a good reference implementation for this, or not really? I think there is, like, an actual good one. Try this PyTorch one just so it's maybe not completely insane. Okay, so here's the RSSM. But what's Silu? Similar. Okay, that's fine. Okay, so there's logit, stochastic. This is like a weird direct port of the jacks, I think. Yeah, this is like a direct port of the jack, so it's going to be equally weird, shitty code. Where all the jacks people need to, like, stop eating glue or whatever. Yeah, this is not going to be really any more helpful than the jacks is, because they literally wrote jacks in PyTorch, which is even worse than jacks and jacks. But these are fine. And then you clip to mins. Okay, so you clip with a min. This is actually good. So I can use this version of it. But then the question is, why does the KL not match up? It's a KL of... I think expected KL, like... What's the expected KL of random? Oh, you know what? Hang on. I can use this for something. So we got post and prior. You get dist stop grad post underscore dist. Should I install this thing to check? Sample dist.dist. So okay, it just gives you the initial thing back. So I just want to make sure this is actually the logits thing. Okay. Okay, so get dist. Stochastic. KL loss. KL divergence. Stop grad. We do KL loss. It's like abysmal how people write this code. Okay, post and prior, which come from self dynamics observe. Which is the RSSM. Okay, so it comes from the output of observe. I swear, sometimes reading research code, it really does feel like I'm the only sane person in the world. Like, abysmal. Okay, so here we have observe. Okay, so here it is. You get items. So it's a dictionary with a bunch of stuff in it. Torch static scan. Obstep. Whatever this dictionary is. It's probably got like the stochastic and the deterministic parts. Is this it? No, obstep, not observe. Obstep, here we go. Post prior. Okay, so you have stochastic, deterministic. That's. Stochastic is a sample. These are logits. Okay, so stochastic and then deter is the logits. You know people good at LMRL here? Entropy overrunning, entropy collapse. RL makes the model more deterministic. Advantages go to 0. Known issue with GRPO. That's an issue with GRPO? You not just have an entropy term on that? That sounds horrifying. I don't know. You can ask around. There are a few people in the Discord, like that guy and a few others. They may or may not answer that stuff because they do it professionally as well. Oops. I mean, like, RL in general will do that unless you have a pretty heavy entropy term. It's not necessarily considered a bad thing in a lot of cases, right? And where was I? I lost my place. Right there. We were doing that. So we're going to assume that prior and post come from this. Dreamy Puffer World model going. It's actually working. We have it actually able to get to max score on the task. It's just very unstable, and I'm trying to figure out why it's unstable. Nah, just cart pulse so far, but this is gonna actually work. Like, this is actually going to work. It's just gonna take me a little bit of effort. Should just be in networks, right? Okay, I see. So this is your logit. And you do not sample from this thing, right? You don't sample from this thing. KLD. Torch KL, Torch D, KL, KL divergence. Wait, what is Torch D? Torch distributions. I see. So they're just like doing this super heavily wrapped bullshit thing. Can anybody tell me though, you do, if you're gonna like sample categoricals from some logits, right? But you want to do KL on between two different distributions, you do the KL between the logits, not between the samples, right? Same as cross entry. Is it? Yeah, but do you do it that way? Tail between the normals. What do you mean between the normals? I'm like confused on this. It's very difficult to actually figure out because it's just wrapped in horseshit. Not samples, yeah. So you probably just do it on... Okay. But then like, I don't understand why these losses are so low. Maybe it's the value loss. Oh. This is interesting. We're not training a value function. Looks like we're not training the value function at all, right? That would be bad. Oh, wait, hang on. I think I have the value loss wrong. Yeah, I have this in the original. Start the puffer, by the way. If you're here, you haven't started the puffer yet, start the puffer. It's free, it helps me out a ton. It's all open source work. Having more stars gets this into more eyes, and then that means I get to spend more time on research and less time looking for contracts, because they come to me. Why do stars help? Because the bigger the project gets, the more visibility it has, the more that companies see it, and then companies come to me asking for contracts, or when they check out the project, they see it as an established thing, and it makes it much, much easier on the business side for me to get my work out there without having to spend my time as much on that. And then I get to spend more time on actually developing the software, making it easier to use, and as you can see here, improving the core algorithms. We like algo dev? Exactly. Because algo dev means that we can actually solve more problems and do more cool things. I don't particularly like algo dev most of the time. I'm fine doing this for a bit. I'm way happier doing like the core engineering on most of this stuff when I can. Well, I do it so that well, I do it because unfortunately we don't exactly have a ton of contributors qualified to do this type of stuff. This stuff is really freaking hard. But it's okay, I do it sometimes. MB returns. This gives you advantage plus value, right? Advantage plus value. And then oh, I see. Is that not it? Huh. That's weird. Does this make sense? Right, so this is always gonna be... Yeah. How the hell does this make sense? Advantage thingy? MB returns. Advantage plus value. Something super screwy here. Oh, is this not normalized advantage? Hang on. You add... Yeah, so you don't add the normalization to this one. What it is. Do like this. The value function blows up a whole bunch, it seems. Also way worse. Let's go check out what is the value clamping that I had before. So we have... This is 0. Okay, so this clipping is not relevant when it's fully on policy, right? But wait. New value minus MB values. That's just MB values. Okay, so this actually is not a clip. Yeah, there's no clamp on the value function of this form, actually. So if I just do this... Get all these value function blowups. already at... It shouldn't have to be a lower learning rate. We'll try it real quick. I don't think this is what it is, right? I was doing the same exact thing, just slower. That's no use. Okay. Sure that this is actually what we want. The value loss blowing up. New value minus MB value. So you clamp this. This is 0, so the MB value is new value. These are the same. And MB returns. Advantages plus value. Ratio is just 1. Okay. Well, this was working with no value function. Nuts. What happens if I just do this? No, the value is supposed to be like this. Oh yeah, what happens if I do this way? So this is the easy mode, right? Basically, this tells us there's something core wrong if this doesn't train. Yeah, so there's something like core wrong here. The value function blowing up. This is the easy training mode, right? This takes out like a lot of the guesswork. So what if I screwed up? Values. Wait, what does this clipping actually do? No, if these are the same, this doesn't do anything, right? So this is telling me that there's something fundamentally wrong, but I'm not seeing it. Hmm. Out of curiosity. It's not this either. Good. That would have made no sense if that worked. Go away, bot. The heck? I've done something stupid, right? All new value, append value. Value takes H and Z. The action. Doesn't take that. Still be able to learn. And value. Value new log prob entropy report terminal action. But you're gonna take out new value. And then it's gonna predict the advantage was it like it couldn't have been training before, right? No, it was training something. It was training something weird, wasn't it? It was training to predict like this thing, right? This what worked? No, I thought this was it. Hang on, maybe I'm just getting confused here then. Oh, hang on. Like this, right? Don't know. Oh no, this. Uh. Yeah, right here, right? This is it. Yeah, this is it. Okay. This is the thing that actually trained. Now let's try some stuff. Predict unnormalized. We still learn this, right? Oh, that helps quite a bit. Still unstable, but that helps quite a bit. Okay, so now is this the thing that breaks it? Huh. Interesting. This still works. Well, the value loss didn't like massively spike. It's high, but it's not like this is massively spiked or anything, right? Okay, well, this is progress. Somewhat, at least. They don't have any instabilities in this either, right? Let me think then. Supposed to be. Thing. "16 segments of length 64." Is this on 16 segments, length 64? Wait, I need to like figure out scale difference then. Wait, we need to be 32x the scale of this, right? Is it 16 times 32? Is that correct? We'd want 512 environments. We're going to do a mini batch of... Because isn't it 32? 60 divide by 2048 segments. Wait a second. Wait a second. Do you want to collect, I believe, one... 8 for 16 steps. 16 steps. I wonder now, if I do more update epochs, is it better or worse? No, we still have instabilities. Yeah, very major instabilities still. Okay, so we should have some concerns then based on this. Some concerns based on this, right? Reconstruct H and Z, right? Go check the reconstruction loss. Where is the reconstruction loss? Yeah, I think there are potentially some detaches that I'm not seeing. Is that the problem? Okay. The world model parameters are optimized end to end to minimize prediction dynamics. H and Z. At equal 1.44 bits. Okay, so this to me is a problem. This has got to be a problem, right? What's your initial KL here? Tiny, right? These are both tiny. This it? The All you guys saying something about how world models can efficiently do on policy on RL, assuming this RL is true. Elaborate on what that was. Well, the idea here is that because the environment is the world model, right, you can just do on policy RL with respect to the world model. You can get data from your environment, you use it to train the world model, and because you're doing RL on the world model instead of on the data, you don't have to actually deal with any of the off policy corrections you would normally need if you wanted to stick a replay buffer into like on policy RL. And that's actually pretty powerful. How is this dynamics? Eh? Log softmax. Thing? Wait. Oh. Wait, hang on. D-log it to 0. Okay, wait, this is D-log it. Huh. Okay. Yeah, so this is the sample. Huh. These look like the same under the log distribution. Super weird. Hey, welcome. Shouldn't these be... You're penalizing... Do this correct? Just ignoring this entirely. You have your sequence model, right? The date. Then you encode H previous X. Going to be initially this. Right? Then you get your D hat. Is this how it works? D hat logits. Wait, because then you can't... What are you doing? I'm trying to do... It's like a Dreamer v3 derivative thing in Puffer, so high performance. I'm trying to work out some problems with the algorithm. Is it the same... Could be something with this, right? Maybe if I go check the reference implementation and how they're doing. The problem with their sampling is so screwy, right? Maybe I can figure this out, though. Maybe I can figure out. Does anybody understand how the representation portion, like the stochastic representation, is actually used in all the decoder heads? Like, I would think it's just that you take one sample, or like one set of 32 samples, right? And then you use the same set of samples for all the decoder heads. I don't know if this is actually how it works, though. Okay, so we get this. Want to learn coding like you, but how? I mean, I have some educational material on my guide here. This contains my best general advice for programming in ML. It's on my X, Suarez 5341. The idea of this stream is basically watch cutting edge RL research done live. I mean, I'm a researcher, I stream all of my work. Okay, so they call get feet on the prior. So hold on. So the reward prior, where's the continue prior? Open L. Well, this is video pred. Where's the this get used? Code is just so bad. Okay, wait, they have reward in here. I don't see it. Oh, here it is. Wait. So they do dynamics get feet of posterior. And then they call this on it. So dynamics get feature and head of feature. Recap progress you've made so far in this saga. Let me not lose my train of thought, but in a minute, yes. I need to figure out one thing first. Okay, so this looks like I am doing it correctly. This doesn't look like they're getting a new sample. So when they make the stochastic state, it's probably from obstep, right? Okay, so Yeah, that looks like I think I have this right then. So unfortunately, then that can't be the issue. So quick recap for you, since you asked. I went to RLC a couple weeks ago. Actually, I've got the shirt on, and I came back with a whole bunch of ideas for core algorithm dev. I was trying to figure out, okay, um, is sample reuse something we really need to think about? How do we improve sample efficiency? I talked to a bunch of people on policy research. I got a bunch of ideas on papers to look at. I did a pretty comprehensive eval of a lot of off policy research, and it's a mess. Like, really, that stuff just doesn't seem to work well. Um, I actually don't really think that there's that much value there compared to other things. Which then, since that takes this huge chunk out of possible algorithms, there are not that many other options. You get to search and you get to world models, which are kind of related in a way, because you need a world model to do search on most problems. Just the use of it is different. So I came back to Dreamer v3. I also checked Efficient Zero v2. Dreamer v3 is a paper that's caused me a bunch of grief in the past because we've did a huge follow-up study to this paper, and half of the reasoning in it is wrong. But I think that the results are still correct, and independently now with mu0 follow-ups, Efficient Zero v1 and 2, we see that world modeling of some type, at least with search, is quite effective. What I'm trying to do now is figure out if there's a way that, one, we can just like get some of the results from this, reproduce some of the results with code that doesn't suck, and then two, get it into Puffer in a way where it's not just like have a super slow, inefficient implementation that is that it's very data efficient but very compute inefficient, where Puffer is very compute efficient but data inefficient. I want to make one algorithm that you can kind of tune so it's either sample efficient, data efficient, or compute efficient. And that is what I'm trying to do now. And the key thing is I'm just stuck on a lot of just minor things with Dreamer and making it stable. I'm running it on a very, very simple benchmark, which is cartpole. It can solve it very quickly, but the learning is incredibly, incredibly unstable, and I am trying to figure out why. There are several reference implementations, but they're all based on each other and they all suck. So there's kind of limited stuff out there that I can actually use. But I'm doing my best to get this stuff into Puffer. That is the extended recap for you. Use a restroom and grab myself a drink, and then I will continue on this. Take two. It is quite possible, I've realized, that I do not have a bug, and it's just fiddly. Hello, welcome. There are a couple differences I have neglected to account for, I believe. So first of all, so by eightfold sample reuse, you're supposed to have most of the benefit, right? Eightfold sample reuse. Even fourfold should be stable on almost everything, but we'll keep 8. Where are their params? Do replay. Where are their stupid hypers? Where they put their stupid hypers? Come on. Here? No. Oh, here it is. So, this is 1024. The batch size. Wait. Batch size, batch length. Environment instances. Turns out the real. This is you're using. Honestly, that's the reason this paper is wrong. So the whole reason that I consider this paper terrible science, and why I wasted so much time on the ablations, they came up with all these clever tricks, right? And they say, look, these clever tricks make our method super robust and stable. But what happened is they threw the clever tricks on reinforce instead of a real algorithm. So when you have even a good implementation of an incredibly weak baseline algorithm, like anything that you will do will give you a performance improvement. Like, that is not meaningful. And then if you actually try to throw those tricks on PPO like we did, it turns out they do nothing. So that is the main problem I have with this paper. I've never said that the result is bullshit, right? I've gone as far as saying that this paper is like borderline scientific fraud, but like I want to be very clear about what I mean by that. But I don't mean that the results are faked or there's like actually malicious anything. I mean it's just like egregiously bad scientific practice. And I'm being very harsh on it because these are experienced researchers who should know better. I would never do that if it were like undergrads, right? But the result of this has been that I've seen tons of people like trying to chuck all these fancy tricks on their stuff, thinking that they do stuff, and like a lot of people have wasted a lot of time as a result. Of course, if this architecture ends up actually being the thing that makes sample F finally work, I think we'll be able to look past that. But like the slip in this paper, the thing that made it wrong, it got past me and the other authors of the NERPS paper, which is like world class RL researchers, right? It got by all of us. We didn't realize until we'd already run like so many experiments why it was the case. Okay, so this n of instance is 16, 16, 16. Sixteen instances. Batch length. It's interesting that they do this. They do that to train the sequence model. Probably do. I mean, we can compensate just by making it 64 by 16. Okay, that's 1024. And then what? So presumably, they roll these out for 16 steps, and then they run however many updates. They run however many updates sampled from this. So that means I guess it's how long this thing stays around for. Yeah, it's just how long this sticks around for, because this is only 1,000. This is freaking 5 million. Okay, that's actually kind of a problem for us, isn't it? We'll come back to this for a second. Yeah, so this is not a lot of segments. Doubt that that makes a big difference, we'll see. Actually, let's also do... We only need 8 to get most of the benefit. I mean, you see it learns. It's just, it's very unstable. You see how it, like, keeps crashing back down like this? Yeah. Okay, and then we get the dynamics losses. It was off to me. Why is this so low? Z starts out as zeros, right? Maybe there's a gap here. I didn't know what you were doing still, I see. Well, it depends if you have an RL background or not, right? So I'm basically trying to get this paper with ridiculously good results, but really, really janky science and really bad reference code to work in PufferLib, which is like really simple, but really, really high performance and stable with good solid reference code. And the result of this should be that we have a ridiculously good algorithm working ridiculously stably with very simple code. And then we kind of just have the field in a really, really good spot if I can do that. That'd be a massive contribution to the field. You know, I'm actually here. The logits. That. Still quite a bit of jank. Is it better? It's faster. I don't know if it's actually better. You still get this ridiculous crash the entire policy thing right there. And it recovers. Couldn't get the SSM to work on anything but cart pull. 100%. I mean, I will take a look at it for sure. We have right here, this is an RSSM, right? Like you see. So I'm trying to make it work. I don't know how the formulation compares to this. Do you understand the KL losses involved with this thing? Because I can't figure out right now. You're supposed to clip these KL losses at 1, right? So, like, anything below 1 doesn't matter. But they never get anywhere near 1. I think I'm doing this right. You know, it's this with detached target versus that with detached target. Batch mean reduction. Log on targets. Just log softmax of the pre-sample logits. Where's X? Oh, I see. You can just see how unstable this thing is, right? Like, it learns. It's just super unstable. I'm trying to figure out what I've screwed up. if anything. Better, at least. Still screwy. Why don't you use VS Code? Because I have, and this is better. We need num m's to match, right? $48. And just do this like this. Back num. Oh, well, this just takes forever to even record stats, right? The games go on so long. Be stats by now. Hmm. We'll have to try it on a different thing after this. I should be able to have cart pull stable. I mean, it's like it's so fiddly. What did I say? I mean, we had replay. This helped. Tuning, I haven't really tuned it. Compute, we already fixed this. Wait, we fixed. Do we need to make just the policies bigger? There's no way, right? It's freaking cart pull. The dynamics loss being weird is still the most suspicious thing to me. Is it supposed to not be a batch mean? Or a batched mean? Maybe that's it? No, that would make it, that'd push it even in the worst direction, right? Get a version where I'm looking for the code. Yeah, go ahead. Hang on. So it's in like on Paul WM or whatever, that branch. I mean, I can kind of just show you. So here, right, the idea is you have your encoder function that takes in the hidden state as well as the real observations. Okay, and then you have your dynamics function that only gets access to the hidden state. It doesn't get access to ground truth observation. And this thing, these both produce you logits. This sample function gives you this codebook type thing where, in my case, you're doing 16 categoricals of length 16 each. The Dreamer bigger architecture is 32 by 32. So this gives you this vector. You flatten it, and then your reward terminal and reconstruction losses are based on both the hidden state and the flattened stochastic part, which is just the flattened stochastic, the categoricals. Right, and then the KL, I think I've done this correctly, is you just take these logits, right, between the encoder and the dynamics, and you do a KL div, one detach the other, and the other one detach the first one, and according to the paper, they clamp these losses so that they don't actually get optimized to below 1, and I'm never seeing these get anywhere near 1. So if I clamp them, you don't learn anything at all. So I'm trying to figure out why my scale is so completely different from theirs. See if that does anything. Somebody fix the graphics for this thing. I'm trying to think what other thing I could have missed. Is there anything else that would affect this? Free gnats. Different distributions leading to high KL. That's what I would think, right? It should be that you get like a high KL because they're completely different distributions, right? The other thing I'm not understanding is, I guess, what portion forces you to rely on the stochastic representation? Like, where do you actually... Not clamping, adaptive gating. Why? Because I mix between LSTM and SSM. I'm trying to figure out where do you even have to rely on the encoding? Oh, wait, it's because the dynamics network. It's that you're supposed to get a gradient here, right? So these reward terminal and reconstruction losses. Yeah, reward terminal reconstruction. These are supposed to get optimized here, which goes through Z, right? It goes through the sampling with a straight through estimate. How does this make sense, actually? Wait, so dynamics and representation loss. Have I done this correctly? Doesn't seem right. Maybe I've done something just stupid. Hang on. Dynamics. Do you get... No, this is the correct one. But then you have this prediction here. This is a decoder. Wait, so... something's screwy. How are you actually training this thing? Am I missing something? Like, is this really how the full thing is trained? How does this make any sense? Because you're training these two things to match each other. But then, like... where are you actually training... I guess it's through this. It's through the decoder. It's through this decoder loss, I suppose. Adaptive scaling rather than clamping. I guess the question I have is if they say that they're clamping to 1, why am I not seeing values in remotely that range? Where's the decoder loss? A reconstruction loss here, right? A reconstruction loss, all obs from MB obs. So, all obs, X. Yeah, you're reconstructing through the sampled Z, right? And H alone does not contain that information, right? Unless I've done it wrong. X. Yeah, so this doesn't take an X, right? This takes an X. This doesn't take an X. So the only thing that you can do is you have to learn through this Z, right? Z logets. Yeah, so this is why the reconstruction loss is supposed to work. And we actually have a very low reconstruction loss, right? Saying that the max value is 1. I don't think so. If you take a max of 1 and this, it's the other way around. This says that if the value is less than 1, you don't optimize it. It would be a min otherwise, wouldn't it? Or maybe, wait, do I have this backwards? I don't think I do. The loss is the max. Yeah, right? Like, it's a max between 1 and this value. So if the value is bigger than 1, you're going to get that value, right? If the value is less than 1, you're going to get 1, which has no gradient. That's different from clipping to 1. Other way around, even. Dang it. Yeah. But then, so Carlos, the question is, why the heck am I not seeing values of that scale at all? Like, ever? Like, have I done something wrong? Because I'm not getting this. Maybe this is the problem, maybe it's not, right? I'm trying to figure out why this is unstable. That's the key thing. Like, I have this, it can solve the environment, but it's, like, super unstable. It should be clipped to 1 if less than 1. Wait. It should be clipped to 1 if less than 1. What did you just type? If less than 1 equal to 1 greater than equal to value. I think this is saying you can literally write this as a max, right? Between 1 and this value. So if the value is greater than 1, you optimize it. If it's less than 1, you don't optimize it. And that matches the text as well. Clipping dynamics and representation losses below a value of 1 nat. This disables them while they're already minimized well to focus on learning the prediction loss. And I guess the one thing I didn't try here... I didn't try... You get negative KL. Wait, you're not supposed to get negative KL, right? KL's always positive, no? Initial baseline. What do you mean you want an initial baseline? Yeah, okay, KL's freaking negative, so that's bad. Oh, wait, hang on. In log probabilities. Hmm. Have I done this? Oh, wait. If I do this. It's still producing negative values. Yeah, right? Not be producing negative KLs. Floating point precision with small probs? Seems unlikely, right? Individual KL terms. Oh, hang on. Maybe I messed it up. Ah, okay. There it is. Okay. Is it a sum over... What's like the maximum KL? It gets arbitrarily big, doesn't it? Yeah, it gets arbitrarily big. Alright, so I mean, this works roughly like before, right? Still super unstable. Oh, actually, that doesn't even make sense, right? You know, that doesn't make sense. It's gotta be this way. Yeah, so these losses are still tiny. Yeah, it's still so unstable. Reconstruction loss. You can minimize it pretty dang strongly, right? I mean, I can do... Do they just, like, get bigger if I do this? Well, no, we don't want to do 0 here. We want to do it... We want to do it here, right? Does this blow up? Oh yeah, they blow up. Yeah, if you don't minimize them, they blow up. Minimum value is 1. You do it here. See what that does. And at least so far, this completely destroys all learning. Right? Like, it just doesn't learn. Oh, okay. Well, it does learn. Okay, so this actually does work now. It's still unstable, though. So we figured this one thing out, but it's still super unstable. Hey, Boxin, we're doing world model stuff. Alright, so this was not the solution to stability. But at least we know that now. And the reconstruction loss is quite good. All the other things, they're actually quite good. Value loss is the one that's still bad. Interesting enough. Weird mix to make the kale well behaved. You know, we are actually seeing ridiculously low entropy here. We could try that mix technique. But, like, they have an ablation that all those tricks don't do all that much. And we know also independently that they're kind of just crap. Maybe I'm overly biased against them. No, KL spikes would be the opposite, actually. So KL would be this going to infinity and nanning everything out. This entropy is in the policy, not the, this, so that's not it. But at least we have this one thing sorted now. Okay, this trick we know is bullshit. So we don't even have to look at this one. We also know that too hot is bullshit, so we don't have to really care about that one. What's the state of things? We have something that's training sort of on cart pull, but we're having stability issues. So the goal is to get, like, cart pull to be sane and stable, and then we throw it on harder problems. I'm using a replay ratio of 8 because this is... Would model scale just screw with it somehow? If anybody wants to help me check for, like, bad, like, there might be spots where there are detached gradients that I'm not realizing. Cherry pick. So... It's not that they're literally running their final thing 1,000 times and picking the time it works or whatever. It's that they're basically cherry picking a bunch of really fiddly, non-generalizable techniques so that, like, the method is not going to be robust as is presented here. That is very expected. But the thing is, Puffer is not cherry picked. Like, PufferLib is ludicrously stable. It's a very, very good library, and I'm using this as the base. You know, we have that optimizer, that batch scale, that, like, setup for everything. So my hope is to combine Puffer's actual real stability with the sample efficiency that this thing can technically get. I mean, the other thing standing out is their model sizes are massive, but, like, it's frickin' cart pull, right? Model size scaling. They show scaling, but it's stable on any of them, right? The only one that's not stable is when they have a really low replay ratio, and even then it's stable, it's just like not... Alright, I use the restroom. I'll be back in a second. And then we're gonna look for gradient bugs. Yeah, I know, 12 million parameters is silly. You definitely don't need 12 million parameters for cart pull, right? Reward and value grads. I mean, no... Yeah, no reward and value, and no Greek. Okay, this is fine. Go looking for new things. This bothers me. Do this. You should probably figure out this section of the code here, right? Let's see if this actually trains. You know what? You wonder here. This definitely breaks it, which is really freaking weird, right? Because it should be the target of the value function, right? You're training a value function to match a target. So something is weird that doesn't work. Part of the loss. Yeah, but look at this, right? New value minus MB returns. MB returns is advantage plus MB values. See how it's weird? Confused about the mini batches. You batch in the env dimensions, right? But then the loop, you don't use the index. Batch is training. So right here, this is a sample over the total segments that we have in the replay buffer. So there are a number of segments with 16 steps each. And we pick a mini batch as a random selection of those. You're training the actor and the value here, right? Heck. We definitely have something screwy here for sure. It should be hatch, right? But this doesn't train at all. Kind of. The reason you use random and in PufferLib use multimodal sampling. Yeah, because I'm just trying to do something simple first. I'm trying to do something simpler first, and I don't think it's going to matter as much because the world model training is supervised. Like, if anything, I think what's going to happen is I'm going to end up applying advantage filtering to the outputs of the world model itself. Like the hallucinated experience is my guess. You have insane spikes in value function. Yeah, I know. But like, why? What's happening? Right? That's not KL spiking. Like value functions getting screwed up. And it's weird because it's specifically when I don't when I detach the returns, which should be like standard. You get here, this is new value, all new value. Like this. And then we do MB returns, can be advantage plus values like this. So how's this make sense? I can do this, but I don't think this is going to help, right? In the original code, where is it? In the original code, MB values comes from the buffer, so this doesn't have a gradient, right? So this has no gradient. And we have a clipped formulation here, but this is off policy clipping, which is different, right? Because new value equals NB value if it's on policy. So this is 0. So this is the same as new value. So this term is the same as this term. So this max doesn't exist, and it's literally just like vloss unclipped 0.5 dot mean. You know, one thing I did realize. At least clamp it that way if I'm going to try to clamp. See if it does anything. I don't think so, but I'll at least give it a shot. It's so screwy. And if I just don't detach it, works, right? So let's see what this does with the clamping. Not stable. Trains, but it's not stable. like way better at least, right? Like even with the clamping, but it's still not stable. The problem. It's still just not stable. This bothers me a lot. To go check Costas. We're not going crazy. Yeah, so this is no gradient. Yeah. Well, this should tell me something screwy, right? Like, this should tell me something is very weird if this doesn't work. Can I predict the returns? I don't like being stuck on this. Not that either. I hope that makes sense either way. I just totally screwed up the advantage estimate, maybe? Fine. Gamma lambda. To be sure. I just want to be sure that there's not some garbage thing weird going on. Okay, good. So it's at least symmetric, right? For sure this optimizes. Pretty quickly, right? I said pretty quickly. Yes, there we go. I mean, we know that I'm confused when I start pasting shit into Grok, because we know that that's never gonna frickin' work, but we'll do it anyways. For the ha-has. Advantages need to be detached. It shouldn't need to be. That function doesn't define gradients. I mean, I'll try it. I'm pretty sure. I mean, I can do this by detaching the returns, right? Like this. And then we can do detach here. Alright, we'll try that. Yeah, that's the problem though, Jess. They're all so bad that they all just waste my time anyways. So like, it's never productive when I paste that in, like stuff in like that almost ever anyways. I kind of don't care about like hopping between language models every other month when like lab releases latest model, right? They're all kind of just dumb. I bet. Yeah, so as you can see, this still does not work. If I detach at all, it does not work. Performs on coding test. Does it? With the new models? I don't know. I honestly don't trust all the people evaluating the different coding models. Because the people who are using these coding models very heavily are kind of terrible programmers anyways, for the most part. Great. No, I never did that. That's what I told Yaxine is that if you wanted to do like pixels training and have it be at least a reasonable speed, that's how you would do it. That's what I told him. Yeah, so this is just doing stupid stuff. It's weird. Benchmark is not great as far as LLM, solving problems above my pay grade. Yeah. Well, I mean, this is not a programming problem, right? This is an algorithm problem. Onto the debugger. Debugger really doesn't do much here, again, because it's an algorithm problem, right? Let's see. Is this doing anything? Nah, this is just like... Well, we do need to figure out why this is happening. Value. It makes a completely different target, right? To make a completely different target? Or not? I actually don't know what that does. It's like thing equals thing plus constant. Maybe that's actually fine. But why does it make such a huge difference? That's like weird, right? Like, do you just do... Not just this, right? Not just like a basic scaling issue? Doesn't look like it. Stuck at 9. The value function is blown up. Other losses are reasonable as well. So weird. Hmm. detach. According to this, then we should detach. I don't think this is... We tried this. We actually tried this, right? Is that letting it cheat in some way I'm not understanding? Think so. Actor from updating advantages. Okay, so I mean, this doesn't... This does not work. How about this? What if I just attach this? Oh. Is this, Hmm. Okay, no, this kinda works, maybe? Okay, no, this does work. Pretty unstable. Does work, though. And this one doesn't somehow. When would that happen? Is it just really unstable? Is that what's happening? I want to see it, like, actually learn something here. Oh, entropy is 0. Hang on, entropy is 0. How's this happen? Oh yeah, it just straight zeros entropy. Like zeroing out the entropy completely. Well, it stopped zeroing out entropy. But just can't learn a good policy, right? And entropy. Super weird. Yeah, it should be detached boxing. I forgot to do that because normally it's computed from previous data, so it's not a problem. But now with it detached... Well, actually, now it is kind of learning some stuff. But it's, like, even less stable than before. Right? Like, this is crazy how unstable this thing is. I have them both detached now. It hasn't done me any favors. I mean, I guess it is, like... It trains and then it crashes all the way back down. It's bizarro. Right? Starts learning and then crashes. Weird. I'd be surprised if that's all it is, Bet. I mean, I've tried this several times in different versions of this, and it seems like there is this actual weird cyclic behavior regardless of what you do. Advantage come from the world model. The value comes from the world model, and the value is going to predict the return, which is value plus advantage, right? Yeah, I think that this just totally made this shit up, is my guess here. Yeah, that totally made that shit up. Hmm. Well, I can tell you Grok is completely wrong, as expected. Don't trust language models, they're stupid. Um, because literally the fact that they use a binned value function makes it impossible for it to still be attached. The only thing I could potentially do here, right, would be I could like do this. I'm basically just wondering if the learning rate for the critic has to be way slower. Thank you, Bet. Yes, please do start the repository, folks. It helps me out a ton. It's free. Click the button. Yeah, so this does not make a huge difference, it seems. In fact, the value loss just like blows up so much like that. Why would the value loss? The world model? Appreciate the puffer support boxing. Yeah. It's like, alright, welcome to this new website. First thing you gotta do is star this puffer. Give the puffer a star. Just how it works on GitHub. What other details are there that I haven't dealt with yet? Thinking maybe it's the RL just moving too fast for the world model, but no, it doesn't seem like it. Yeah, this just doesn't do anything, and it's the entropy is 0 still, which is ridiculous. Why are we at 0 entropy? That stuff is weird. The detached stuff is weird because, like, you should never have attached targets. Like, that doesn't make sense. You're basically just predicting yourself otherwise. Like, you're predicting your own output. I don't think you do need the gradients to flow through returns and advantage. Advantage is basically just like a priority weighting. The real gradient comes from negative log prob, right? Good, at least. Where does entropy come from? All entropy. Logits. I mean, it's like... And the fact that this does work, if I just do this... Yeah. But it's so unstable. I had it more stable earlier today, arguably, right? Eh. Scale penalty on... Well, that's just an entropy coefficient. You can do that. But the thing is, I already have one, and it shouldn't be pushing entropy to 0 immediately. And if you see here, it's not doing that, right? Like, in this case, it's not. Like, there is reasonable entropy present. But for some reason, right, there's this huge difference. If I just make if I detach the targets like this, which is what you should do, the target should be detached as far as I can tell, right? It just doesn't learn anything. I have no idea why. World model has its own. No, the critic is learned only through the imagined data. There's no value function learning happening from supervised data. That would be off policy. Like completely off policy as well. I mean, you can see it's like trying here, right? It's like it's bouncing around at least. Hey, Satya. More successful, I'd say. We have something actually running at least. Okay, so it is actually kind of doing something here. Let's go look for different bugs. Where does this state come from? State. We're just expecting this to update in place, right? This match. Yeah, so you get all zeros here. Which the value function RL. The value function is learned through RL. The value that is part of the RL right now. It wouldn't work without it, Satya. Right? Critic is learned end to end as part of the hallucinated experience bit. Sample Z logits. Forward eval on Z. State. And previous action. Yeah, so state gets updated in place, right? Is distribution to approximate. Yeah, so Z is a sample. I'll show you. Okay, so here's sample Z. You get Z logits, which is just 16. Okay, and then we take softmax of the logits to get probs. And then we take 16 samples of the 16 dim categorical, and we make a 1 hot. And then we return the 1 hot with the straight through estimate, like this. Does that make sense? And it runs. Not doing super well. Have any other ablations I missed? Nice as a baseline. Yeah, well, it's not doing very well, and like oddly, it was doing better when I had bugs in it. Like it was doing better when I had. If you, it does way better. For instance, if you don't detach the returns, you do like value equals advantage plus values. If you don't detach the value target, it does substantially better. It's still super noisy though. Like I've seen it solve very, very quickly, even impressively quickly, but the policy is very unstable and it like just crashes back to random. There are additional tricks. I know for a fact that some of those tricks do nothing. There are others that possibly I might need, but the thing is, like, it should just work for cart pole without them because they're all relatively minor, except KL balance is like kinda relevant. Yeah, so that one I have basically complete proof is bullshit. So that's like a fancy thing that they added that actually doesn't do anything. Which is one of the reasons I don't like this paper as a scientific contribution. Because half of it's wrong. But like, it's just pushed entropy to 0 here for no apparent reason, right? Categoricals. Add Unimix. Do they have an ablation on that? I guess they don't have an ablation on that, so I can try that. How do you implement that, Sacha? Is that just uniform added before you compute sample or what? Something when together? All the tricks? Not really. The thing is, like, not doing simlog on the rewards is like if you just clip, it's very close. And then like a few of these don't really do anything. KL balance is I think the only one that's kind of fine. Probs equals Oh, I see. So it would be like this, right? You can do that. I don't understand what this thing is doing though. Like, it's ludicrously unstable. Like here, I'll show you something weird. You want to see something real weird? If I literally just get rid of this detach, if I don't detach the return, which is like clearly wrong, it learns like way better with the returns not with the returns attached. Isn't that weird? And the thing is, it's still like, it's still super janky. Like, you see, it almost had the task solved, and it like oscillates around a whole bunch. See, like that's almost solved, and it just like is super unstable. If you don't detach, it buys exactly. So like it should be worse, right? So why is it that it works so much better with it attached? Um, so we have the typically we will normalize the rewards, not the returns. So the returns are sort of bounded. They're bounded because the rewards are bounded. I mean, I suppose I could normalize the returns as well. I doubt that helps, but I can try it. Okay, maybe better. I think it's still super unstable, right? I mean, that's better for detached, though. That is substantially better, at least for the detached version. Turns normalization. Yeah, it's forgive me when it's difficult to actually trust their tricks when like I literally have 20,000 hours of 100 ablations. Um, basically saying that the science in this whole paper sucks. You definitely don't need quantile return normalization. Like, there's no reason you should need that. You can see how unstable this thing is, though, right? On what should be a very easy problem as well. Let me see what happens if I get rid of this, flipping. You see? Or maybe crazy unstable. Which, I mean, is so obnoxious because it's presented as, like, you know, the stable algorithm from God in the paper. I wouldn't be surprised, though. Well, this trick here seemed to actually help. We just like hyperparam sweep everything at this point, or is there like still core stuff? Core stuff missing? I mean, this is at least closer now. With the value normalization. Copy core hypers. It's tough to copy core hypers because he has like the slowest, stupidest thing ever. I have all the batch sizes multiplied by like a fixed big value. I'm not trying to match it in samples initially. I'm just trying to get something stable. And larger batches should, if anything, make it way more stable. I've copied like some ratios though, as best as I could. We're doing we've got like mini batches of 32k steps. We're doing 8 updates. So 8 updates. 8 separate mini batches. We're collecting the same like 32k mini batch from the environment at a time. Got a nice big buffer, so it should be a pretty slow moving. The data change should be pretty slow moving. And this is like way closer. Maybe I should look at this thing. Is this from the original? Wait. Losses provided as... I didn't see this in the paper. Where is that? Oh, here. This thing? Hmm. Well, to be fair, Satcha, if I get this working very nicely in Puffer, and like we actually have a clean way to trade off between compute and samplef, one, on the open source side, this basically fixes the one big remaining thing in the whole field. And on the other hand, right, like I can directly leverage that to go sign contracts to help me fund all this work. Like very, very easily, because I've had several very large companies ask me for like that sort of a trade-off. So it's both. Like this directly goes to enhance the science and all the open source stuff we're doing, but also helps me on the company as well. We're working on it. Yeah, this seems very poorly controlled to me, honestly. This seems like, yeah, this is very poorly controlled. Is there a huge difference actually? Hang on. Let me see if that made a huge difference. Just normalizing the values, the value target. To let this thing run a bit. Going to PhD, advisor found topic, designing good and stable recipe for multi-agent world model. I don't think anything changes because it's multi-agent, Satcha. I don't think anything changes. Just that you need slightly fresher data. Interesting. So that actually seems to have made a pretty substantial difference. I would wonder why. Well, it does eventually. It's just like so ridiculously unstable, right? Okay, well there's definitely a difference then. I should probably run this, commit this if it's stable, and then keep going from here. Okay. I'll be right back. Model will probably stay unstable unless you handcraft these update ratios. What do you mean handcraft the update ratios? But do you have any idea why it's unstable? Like, normal RL was very unstable before I did Puffer, right? Well, I'm sweeping some of the hypers here, or attempting to. We'll see if it finds anything or not. You know, oddly enough, like, the sweeps I've run so far have found, like, nothing. It's really odd. They've actually just found nothing. I will be right back, though. Give me a minute, and then I'm gonna think about what we do next on this to make this, like, actually reasonably feasible, right? Right back. Maybe experiment with distribution, latent. You could do that. This done anything? Nope. Form it like this. Am I understanding the training process correctly? I suppose this shouldn't matter that much, right? Sampling from it. Yeah, right, but like, so are they're sampling a certain number of trajectory segments, right? And then they're training the world model on those segments, but then they're also generating a certain amount of experience. So are they training the world model on the same amount of imagined segments as they're training the or they're training the actor on the same number of imagined segments as they're training the world model on a number of real segments? That makes sense? Yeah, exactly. So I don't see it anywhere in here, but Yeah, so this is stop grad on advantage here, right? They don't have a stop grad on the critic. And from sampled segments. Yeah, that's what we're doing. Yo, Sacha, they don't have a stop grad on this. Is this just an oversight, though, or... Why the heck is this a log loss on, Oh, because they have it bucketed, right? Yeah, so then if they have it bucketed, it's impossible that the targets have grads, right? Yeah. So it has to be detached. Does it actually... Wait. Sacha, I don't think it even makes sense to do this value norm, does it? Even though it's, like, working empirically, does it even make sense to have this norm here? You can't just normalize the returns like that, right? Because then the value no longer has the same meaning. Am I wrong here? Like, you can't do this, right? Like, you could do a fixed scale, I guess. I mean, I could divide by the mean. Okay. I mean, how the heck is it the case that it trains on the thing that makes no bloody sense? And it doesn't train on the thing that should work? I mean, I guess it sort of does train, right? It's just pretty unstable. Maybe if you replace one hot with Gaussian. Didn't they say that was worse? The entropy and the value that are, like, bouncing all over the place. To be fair, this actually is learning if you just give it time. It's just very unstable. It was, but it worked as well. I mean, I might do that as an ablation, right? This should not be the thing. You'd agree, though, this shouldn't be the thing that's completely destabilizing it. Like, why does it do this thing, right? Where it just dips a ton, and then it, like, shoots back up. Right? Isn't it weird how it's, like, oscillatory? Do it on long. Budget of environment samples. Presumably, you'd want more fresh data. It should make it easier, no? The problem is Dreamer is just, like, stupidly slow. Like, we're not gonna wait 3 hours per experiment every time I need to run cartpole, right? They literally will spend 3 hours per experiment on Atari 100K. Not a good thing, that's a problem. Zero entropy, you see? Zero entropy on the policy. All base arrows. Well, that's the purpose of it, but having fresh data makes it easier. Because your initial data is going to suck because your policy sucks. How it affects the convergence? I'm going to have to just spend more compute, meaning I'm going to be sitting here waiting just all day while I'm running these dumb experiments. Like, if you actually go to the Dreamer, if you actually use, like, their batch sizes and stuff, you're going to be running your GPU at 5% utilization. Yeah, so this here is, I mean, it's a zero entropy policy, right? How does this happen? Low as well. Constant oscillations. Well, do we know why it does that? I mean, so far on Breakout, it just doesn't work, right? It's just entropy crashed to zero. Maybe that's a clue for us. Is that is that this revolves around entropy crashing? Yeah, like it's instantly set entropy to zero. Okay, well that's stupid, right? Why does it have entropy set to zero? But why is it setting entropy to 0? That's not the entropy of KL, right? That's the entropy of the policy. That's not like KL spike. That's the policy. Being diverged. Why? No, that's not diverged. Diverged would be the losses explode and it nans out, right? It's just decided to optimize, it's decided to determinize the policy. The opposite of diverged. Like collapse to, fix policy on this stupid thing. Good algorithm. Accidentally setting discrete to continues. What do you mean setting discrete to continues? Passing all logits. So you get Z samples here. Yeah. Well, our RL is generally pretty good. It's PufferLib, Satcha. Okay, so there's your multi-hot Z thing. And there's your initial H, which is going to be the same for everything, of course, because it's just the initial 0 state. There should be, yeah, unique Z logits. And then you're passing the sampled version, right? You're passing the samples here. And then you sample from your logits. And to detach rewards and terminals, because they are getting trained supervised. That's it, right? Discrete path wasn't returning logits tensors. Discrete path. But this sample is only supposed to give you... Wait. Are you supposed to be using both of them? No, you're not, right? You're not supposed to give it the logits. So the sample comes from the logits, right? So the logits is deterministic. You're not supposed to give this the logits. You're only supposed to give it the sample, right? The sample and then the like the GRU state or whatever, right? See. I'm pretty damn sure I've done this, right? Concatenation of H and ZT. So ZT is a sample, right? Yes, Satcha. I just need way more entropy. Wouldn't make sense to me. Well, now it's not collapsing. I mean... It crashes down constantly. The value loss, like, spikes up. I mean, it's more consistently cycling now, so that it's not just, like, collapsing. It does... No, there's no way it's managed to collapse entropy with a bonus that high. That's crazy. And it has a very low reconstruction loss. That's ridiculous. Oh, fine. Well, that's, like, entropy is usually, like, 0.01 at the most. Right? So it's ridiculous that you need to even do this. Encode. Well, I mean, the world model is getting its data. Environment. I mean, you can see, right? Like, if the world model is collapsed, I'd have to be doing something like massively stupid, no? I'm actually curious what happens if I do this at this point, which is to say, constrain it to the actual on-pal data. Huh. Like, that's supposed to be massively easier, but look at the entropy. That's ridiculous. Dang. Value function is really sensitive to scale. Really sensitive. It's still not great, but that's like workable, right? So unstable that it... Entropy crash still. It's doing something different, though, than you'd expect, because... Wonder if there's some sort of clipping analog you need for this. Okay, so never actually full solve the problem. But substantially better and non-determinized policy. If I do this, also seems to help, right? They have this thing bucketed. See how this makes any sense. Just need the value loss to be normalized. Or is it literally the targets? They're obnoxious. They work sometimes, but they're very obnoxious. What's happening? See if this does anything. Okay, no, so it is something screwy, it seems, with the targets. Oh no, there it goes. Well, I mean, at least this is, like, more correct, right? This you're actually allowed to do. Doesn't mess with the returns. I mean, you're getting cyclical performance all the way up to solving it. That's, like, really clear cyclical. That's so weird. And, like, Well, it can't be the world model doing that, right? Can you screw up the world model with the actor? I guess you technically can, right? If the losses get out of balance. I assume this doesn't just fix it, right? Not just as simple as them being slightly off balance, right? This actually fully crashes it. Zero entropy. Yeah. There are no production grade implementations of any of this crap for anyone wondering. It's like all bullshit. Yeah, it totally is. Production grade just means your code sucks, honestly. Most of the time, like if you're going by what it like the actual code whenever anyone says that, it just means your code sucks. Ah, hang on, this is something. This is the only thing I was looking for, which is I like already kind of thought that I'd missed. Let me go find the existing reference and see if I can see where they detach a gradient. What the heck even was that paper? Oh, like tiny improvement. 10 training FPS. It's hilarious. Alright, so they stuck a giant ass transformer in and it's actually like not a big difference. So it actually does kind of make sense that you could go transformer based with it does kind of make sense you could go transformer based with the world model because you actually get some parameter scaling, it seems. But yeah, this is not necessarily... I'd probably look at search before that. Where's the frickin' train thing? Okay, so here's your dynamics thing, right? Do they have this in the paper somewhere? The stop grad? If the actor is not going to backprop into the world model, then you basically would have to detach both of these, wouldn't you? H and Z. Does that do it? I don't think that'll work, right? Uh, Interesting. That actually does... Well, we'll see if it's stable. Is this what it's supposed to be? So it's like, hey, don't backprop through the world model. It's still not as stable as you would expect it to be, and this is a relatively, like, well, a very simple problem as well. H did get the encoding. You see, it's like the crashing thing is still a problem. They do have separate learning rates here. Let me try scaling the actions real quick. Is this still stable now if I do it this way? Or no? Okay, that's actually still stable enough. Let me try like 0.2. Okay, that's something. So screwy. What are all these damn papers coming from? Oh, you know what? These are like kind of random. Yeah, these are like super random. I think a lot of this stuff is kind of just people like just jumping on the popular thing because it got published recently in Nature. Okay. Um, that's a problem. I wonder if now I can stop with the V-loss scale. Because this thing was janky, right? Can I do this now? Looks like I can. Yeah, okay. Well, that's way better. Yeah, it's still not going to be fully stable is my guess. But that's like markedly better, right? Now we'll see if it even finishes at that level of perf or if it collapses back more permanently, but at the very least, that's like markedly better. Don't need any of this return scaling. That doesn't make any bloody sense. Get rid of that. Now the question is, why is it collapsed like at all? Is this tunable? We might just be able to tune some loss coefficients actually. It's working like this. But cart pull is still a super trivial problem. Okay. Still way better. Do we see anything on breakout yet? The result of this. Zero entropy on breakout instantly. Instantly zero entropy, huh? And yeah, it's very easy to learn a world model on nothing, right? Complete collapse. Hmm. Yeah, this is still not better than I mean, this is still a trivial 4. You need to get like 8 or whatever, and then it's non-trivial. And just like add some entropy and have this thing work. Too big or too small. It's definitely not too small. Larger batch size should just be better if I can keep up with it, which I can here. Entropy 0 again. This is like some specific quirk, I think. Because entropy loss should definitely not be 0. I wonder if it's just like not getting added somehow. Yeah, there's no... Hang on. Alright, well, it is getting optimized. I have no idea why. Ridiculous entropy scale. This has gotta just be way too high, right? Yeah, I think that it's just like the collapsing problem. I think 05 is about the highest you'd ever really want to play with. I mean, even this is ridiculously high. Why is it so difficult to get this thing to do like anything? My gosh. This is the like only non-trivial task. I mean, the first non-trivial task that you would try to get it to do. Right, like this. I do this. In Horizon. Thanks to your X post, learned a lot. Comfortable with Python, C and Java, learning Go recently. What's your take on reading Learning Go book? Unique features of programming language I have to prioritize. I have not ever written any Go. I'm generally Puffer. Everything is Python and C. All the environment stuff is in C. Neural net stuff is in Python. Go seems fine. If you know a few other languages, though, I don't know why you would have a language specific book ever. Just like build stuff and reference the docs, pretty much. Also, unlearn Java if you can. Ugh. Well, I can't expect it to even do anything with this entropy coefficient being this ridiculous, right? Get rid of this bot. Trying to replace Java with Go. Well, hopefully the Go code doesn't look anything like the Java code, right? I know Java's just like Java's a language where, like, literally at the language level, it prevents you from writing good code. Like, you actually cannot write good code in Java. It's just impossible. There are not that many languages that do that, but Java is one of them. Oh yeah, I had to learn Java in not 2008, when was it? Like 2010-ish, maybe? It actually poisons you as a programmer. It takes years to unlearn Java. Okay, well, at least I have this thing, like, kinda stable, but it's not doing anything. That's not great. How to unlearn Java quickly, write more C. Just like, I mean, honestly, look at some of the puffer environments. It's just really simple procedural C. And then you realize, oh, this would be 10,000 lines of code and a 10,000th of the speed in Java. That's a completely stupid language. Why would anybody ever write code that way? And then you've unlearned Java. There you go. Yeah, at a lot of companies, you're just not going to be able to get away from C++, unfortunately. But yeah, if you can get away from it, definitely worth getting away from it. It's so weird how this thing is like. Well, to be fair, I mean, I suppose cart pole is such a weak baseline that getting something to work on that really isn't indicative of anything else. C sharp. Um, honestly, could be worse. Like, it's used like embedded into a few different game dev things. Like Unity uses C sharp, right? It's still so weird to see that this gets solved. Like, you get a good policy on this so reasonably. I mean, it's super unstable, right? But then you don't even see it go over random or like trivial policy perf once on even something like Breakout. The engine required it. Yeah, it's probably Unity you were doing, right? Heck do we do about this though? Honestly, what do we do about this? Purple. We did drop the learning rate a little bit. New batch size, batch size. I'll do this, but there's no way this makes the difference, right? Okay, so reconstruction loss, very low actually. Eating baseline breakout. Yeah, so the thing is, cart pole is just so easy. Like, literally anything will work on cart pole. Any place for transformers in RL? Yeah, it's just that they're slow. Like, really slow. We'll probably do that at some point if I can get something that's, like, at least reasonable. So obnoxious, though. I'm trying to think where we go from here. So we have something that, like, is decent-ish, like, mostly does cart pole, and it's just so incredibly unstable on everything else. 10 is above random if it keeps that for more than, like, a data point or two. It's not good, though. The heck of it. Let's just make sure it's not this stupid balancing thing I hacked on. I don't think it would be, but... Okay, no, yeah, it's still messed up. It's like very close, but I know it's just like going to one wall or whatever. It holds until training ends. You sober for math on Saturday night, yeah. Huh. Thing. Right, so we can start messing with model scale and stuff, but is that really what we're doing? We have for our decoder. Terrible. The reconstruction loss is like super low as well. The dynamics loss. To see. And the RL on this should not be bad, right? We tried these detaches. I mean, this very much limits it technically. Let me see this. But I think that, like, screw up the world model even more if you don't detach. What else can we do? What else can we? Anybody have any ideas? Stupid paper, I swear. Adding noise always helps. Nah. No way. I guess if we're gonna use a benchmark, we need a benchmark that we can actually solve. We may as well do this. And then I suppose we can figure out the stability issue on this. Let's start going through a few different options. Instead of just sitting here like thrashing, right? Alright, so first one. Stronger dynamics and representation losses. Does that do anything? You can still learn. You still have the same instability. Go even lower. Just to make sure it's not. I don't think this is it, for reference. But we're kind of just going to go through and exhaustively validate some stuff. Okay, so this is, the environment is solved right here. And then it's going to collapse. It seems. Yeah. Do you see how unstable that is? So it's not because of this thing. Let's make sure we'll get our baseline. Be the replay buffer? Absolutely could be. Do you have ideas on what to do with that, though? This should solve, right? Actually, it does seem that this does something, right? Okay, it actually seems like the clipping, was the clipping too low? $1.5 mil to get the unstable. Okay, so yeah, that's actually a big difference. It's still unstable, but the lower clip actually makes a difference. It's still quite unstable, I would say. So, next thing. Do we go to the original codebook size from the paper? Nah, that doesn't seem like a good option. And it's still crashing pretty bad. Look, it's at 100 there. Definitely should not be doing that. Show us your socks. No. We're here for research, not for random weird degeneracy. I think you opened the wrong website. You have samples. And to be clear, I think, this is actually good that we're detaching here, right? Or is it just, like, noise? Okay, no, there's a huge, huge difference. Like, it still can learn, I think, but there's a huge difference. Like, the gradients are fighting each other. I already tried clipping even more. So, that only works if the guy you're talking to is actually ugly, my guy. I know I look good. Get out of here, find another stream. Get rid of this guy. Alright. How's breakout now? We can try it, but I very much doubt any different. Yeah, no. So, I mean, we're clues, right? It solves the task and then is unstable once solved. Those are our clues. So this thing here is not solving, right? Needs to go, like, at least to 7. And you should basically be able to do that instantly with a well-tuned, well, pretty much anything. Alright? I'm actually curious if with the fixes, it's still wonky, like if you just don't detach returns, if it's better. I don't think this ever solved the stability issue regardless, though, right? Okay, it's also, like, at least now it's, like, worse if you do something wrong. So now at least we're directionally correct. That's kind of correct. We try this loss thing with the new scales. KL div. Strengthen KL div penalty. Which KL div penalty? There's not a KL div penalty. There are KL losses of various types. Okay, well this doesn't make a difference here now. It's just the divergence. Boss. Model optimizes up, model optimizes down. I wonder if this 01 rep loss thing is a mess. If all these losses like totally unscaled relative to each other is not great. Seems more stable, but yeah, it's actually like jumping back up to the top. Okay, there's entropy. Entropy can technically screw you up. I don't think it works without it though, right? Let's see if it works without entropy now. Oh, okay. This will at least tell if it's entropy loss causing the crash, which I doubt it, but you know, it's possible technically, so we'll check it. And no, it seems like it is not. It's not entropy causing the crash. Okay. Is it the learning rate causing the crash? Okay, so does it maintain this? No. That's the same sort of qualitative crash down, right? With a much lower learning rate. So it's not that either. Okay, what else are we left with then? You know what? Let's try. Do it. And 16. Let's see. Grit. Things obnoxious. Do this. Rec logits, let's do that. Even better. Let's see what this does. Okay, super unstable, right? So it's not coming from this being sampling. The instability is not coming from this being sampled, like sample based. Does come catch back up. Okay. Actually, let's test the straight through estimator. Okay, so without this, learning's way harder, as it should be. You have no way to backprop through this thing. Massively harder. Okay. So if I do logits instead of probs, what happens? Okay, also not this. We've ablated this a little bit, I'm happy. Happy with this at least. See? So these are all correct. They're all H and then Z. Fine. Still have the instability problem, right? And it doesn't seem to be value blowing up. It really doesn't seem to be anything blowing up, right? None of the losses really are blowing up at all. The reconstruction loss, that gives us a better representation. So it's still super unstable, right? What other stuff have I not tried yet? Like, that's a lot of what I can do. Yeah, like, look at that. Okay, I can go check terminals, maybe. So, try this. What this is supposed to do is set the obs to something new on terminal. Hmm. Not perfect, but that was way more stable for a bit, right? Okay. That was way better for a while, though. This is state. Terminal is set to 0. The terminal set to 0. Oh, you also need a prev. Okay, so this should now be correctly resetting. Okay, so we're still not there. What other stability crap is there? Like, what else could we be missing? That's Okay, so this is now can change the imagination horizon, right? Still works on the longer horizon. Okay, yeah, it still collapses. And in about the same amount of time. It's just that it's running slower. So it looks like it takes longer to collapse, but it's actually just running slower. Unfortunate. Where's X come from? Oh, hang on. Still unstable. Better, though. So it would seem. I guess we'll let this run for a bit and we'll see if it, like, actually ultimately collapses to and doesn't recover. Yeah, like that, damn it. Okay. What would the heck causes this type of a thing? That's ridiculous. Value loss is quite high. Very high. Having trouble predicting reward. Okay. Multiple. What? That should not be the case, bet. Oh yeah, that branch, the imitation, that's something different though. So I have it set up so that you're imitating like one mini batch exactly, so it's fully on Paul. There's something different going on there. How we get this stupid thing stable, man? Thanks. Get this like the same qualitative trend over and over again. No matter what you do, what would this mean? It optimizes, and then it unoptimizes. Isn't that odd? Something biased? Yeah, you looks good. You have gradient clipping, yeah? I don't know, maybe this needs to be need 0.5 grade clip? Is it just instability in the optimizing? I doubt that. I guess of the numerical things, though, it's the more likely for params. Well, we definitely don't want to go to a shittier optimizer, right? Because then we just expect to have this problem, but even more. How big is the replay buffer? Is it holding enough? I think I made it like 4 million or something. I mean, we are going through the replay buffer way faster than Dreamer is, I suppose. Because we're doing like a ton of samples. I guess I could go try that. Network should definitely big enough. It's freaking cart pole, right? This actually has been slightly better. We'll do this so we have stable numerics. Let me try one other thing, which is if I just like crank this, that should do something similar, right? You get more updates on your data. Now the problem is it takes forever to even figure out if this does crash. But it looks like it does. Okay, similar thing. Way less data. I tried learning rate already, bet. I think that they had it like the thing is like, look, 4,000 steps per second. Yay, we're so good at reinforcement learning. Like moron parameters. Like you do solve the thing. Is it gonna be any more stable? I doubt it. Let's say. Still unstable, just recovers faster, yeah. And I don't understand, like, we're kind of seeing why can't I just do this? Way faster, no? Something about these big batch sizes, actually. Let's see if this is stable, I'm curious. It's actually less stable. Zero wrapper. That is honestly way less stable than before, like this. Which is really weird. And you have it solved in, like 100k steps, right? I just want to see. Because that would just, it would give me information if this did something. Hmm. It's like close. It needs to actually stay above 7 for a little bit for me to be confident. Overfitting for cart pull, since nothing will break out, now it's slower. Yeah. Yeah, I know, bet. It's gonna be difficult to get a new algorithm working. And like it just requires a lot of testing and fiddling. But this does actually like anything above 7 is above random. So we're not really getting a ton of samples, but if this thing stays above 7 at any point, I'm pretty sure that there's something wrong with our large batching formulation applied to Dreamer. Yeah, look at that. Still solves under 20 seconds. Locks at 1.0 perf. Want me to PR it. Learning from the STM since I have a mixing action. Paste. Yeah, you can I mean PR it to a new branch obviously. But yeah, for sure. I'll take a look at it. It's actually kind of tough to tell whether this is doing much. Oh. You also got to keep in mind the estimates are way noisier because it's fewer data points. Value loss. Yeah, it's low though. You should be able to get stable, consistent 200 right on cart pull as well. It shouldn't just recover fast or whatever. Go look and see how we can get that to work. I mean, carp. Wait, this is the wrong end. Cart pull is supposed to literally solve in 3 seconds. Is the other thing. Still solves in 3 seconds. Yeah, that's like what it's supposed to do. It does seem that there is something to do with the batch size, though, right? Just make sure it's not this. Stable? Not fully stable. The thing is, the replay buffer is so big now that we have literally all the data that we've collected from the whole training right here. Shouldn't be inherently. Pretty good. It does destabilize, though. You see? Nowhere near as bad as with the data buffer moving as quick. But I mean, it's still like it's not even getting max score at all anymore here. Kind of weird. Wonder. It should be like this should be so stable. Hang on. This version especially should be super stable. That makes a difference, right? Hmm. Hey, James. I'm trying to get frickin' world models to be stable. Such a pain. I think it's just these coefficients, right? I mean, I guess technically it could just be the coefficients. Seems wrong to me. And it's still not good enough because it doesn't do anything on breakout, so it's like close to perfectly solving the trivial task, which is not like that's not a super high bar. Update. This does like nothing on breakout, right? Try Pong as an intermediate. Pong is substantially easier, but like still harder than cart pole. We can try like this, right? See if this does anything non-trivial. Pong, I know you're supposed to be able to solve in like 100k frames or something ridiculous. We are getting absolutely zero signal. Gamma lambda, right? Need gamma lambda to have any hope. Yeah, just not at all, right? Literally just, huh? Yeah. Oh yeah, I forgot Pong has like a really obnoxious learning curve as well. Not a great environment for quick tests if you're not actually solving it. But here I'm pretty confident we're just not either way, right? Mm, I mean, better than random, isn't it? Okay, yeah, it's definitely better than random. Yeah, it's getting like 1 point or whatever. Usually Pong has a very aggressive learning curve though, where like when you learn anything on it, you learn the whole end very quickly. Seems not to be working here. I'm trying to remember. There were definitely things where I couldn't get it to do anything at all on Pong. So, progress. Not a lot of progress, but it's progress. GitHub AI commit description. It won't let me comment. AI commit descriptions. I don't have any AI commit descriptions, right? Oh, they like the platform added that as a feature, I guess. Okay, so like unbelievably painfully slow, but this thing does learn a little bit of Pong. I was hoping it would like start learning fast and we'd actually get to see it do something, but at least we have like some confirmation other than just cart pole. That said, we probably should just do this. Go to the code book. Okay. There. Okay, so what paper is that? Oh, Mamba. Wait, Decision Transformers offline, isn't it? Decision Transformers for offline. At least the original was. Yeah. Interesting that this doesn't just instantly scale up. Think that this should just scale up, no? Doesn't seem to. Oops. $19 million parameters on friggin' cart pull. Behavioral cloning is very easy to get to work, actually. You can do that in an hour if you just, like... There's even a branch on it. It's really, really easy. I scaled this thing up, and it's supposedly this is supposed to work better. Okay, wait. Recurrent units. 8D. But presumably this is still not stable, right? Yeah. So, I mean, all we're accomplishing here is making it fucking slow and useless. Just as unstable as ever before, if not even worse. Lovely. So, I mean, it really should not be the model scale of anything, right? I'd just, like, it really shouldn't be. Yeah, there's a behavioral cloning branch. Just not happy with this thing at all. The fact that I just lack a principled way to even get this thing to work better is bothersome. I I mean it shouldn't be. Unless there's like some key fundamental screw up. Which I guess is possible. It's like part pull's so easy you can learn it even if you've totally screwed something up. I like breakout. Well, breakout's too hard at the moment because this algorithm is too crap. You just see. Make sure I fully understand. So annoying to like an all Saturday just looking at this stupid paper. Well, I'm also somewhat grumpy because of that. I've run I've been running at least a 10K 6 days a week, lifting 5 days a week on like 1,000, maybe even 1,500 calorie average cut. The representation lost back to its original scale. When I run out of time to work on this, I really don't blame all my colleagues who've left this field though. Like, just the quality of the science in this space is just so abysmal, and the code is just so ass. It's like a stupid cursed field most of the time. Like, literally interact with any published paper, and it's just a stupid field. Like, I keep forgetting, like, what a big deal the puffer trainer is because I use it all the time, And it's like, oh, look at all these publications. It's like, oh, you do so much better than PPL, and they don't fucking work. None of them work. You go implement them. You look online, and people like a few people got them to work. It took them literally 6 months, 4 to 6 months to implement one paper with reference code. Takes you as long to like replicate a paper as it took the author to make the original paper. That's like no value. SPO. I still don't understand why that algorithm is supposed to work. But I tried off policy stuff, bet it was ass. The paper lacks literally everything. I have 20,000 hours of ablation showing that like their reasoning for half the paper is wrong as well. It's just stupid. Stupid paper. Stupid researchers, I swear. Oh no, this Dreamer paper. Take hidden. LSTM state, right? MA. Then where do you get Z from? You do have Prev Z, right? Then you take Z, you take state, you get previous action. Do your encode. H and X, you sample. Actor and value, use the sampled version. And you're good, right? Between the old latent and the new latent. You don't have between old latent and new latent, but you do have between the encoder and the dynamics function, and that's already being optimized well. This seems fine to me, right? You have your states. Here's your obs. Get your previous action. Your previous z, which both start off as 0. I have them zeroed up top, right? Yeah. And then you have your previous action. This seems fine to me. Sample a random batch. You get all this crap. Doesn't matter. Literally, the env isn't even like the env has one and -1 rewards anyways, or just I think it's just one. Yeah, LSTMH. Let's see. Okay. On the first time step for the or actually on every time step you get the real obs. Encode Z, state, previous action. You update previous action here. You get logits from the encoder. You get hallucinated logits from dynamic. You sample the real logits, not the hallucinated ones. Reward, terminal. It's straight through gradient estimate on Z. You get reconstruction loss as well. Append everything, stack everything. Reward loss is mean squared error. I could take another look at these offsets, but I'm pretty damn sure that these are correct. I mean, I can do this, right? And I can check. Pretty sure this breaks it. Terminals matter a lot for cart pull. Hmm. Well, that's awkward if it even works. Well, it certainly isn't better. Pretty damn sure, though, that you don't. Because yeah, like, you get observation. The environment returns you everything. Observation, reward, yada yada. So you need to take you take all your reward predictions. And then you offset them like this. Yeah, the objective is wonky as hell. Try explicit normalization on the obs, I suppose. Well, we have the KL here. I changed the free bits to 0.2, which seemed to help a little bit. And it keeps the loss just above 0.2. And when you go to hallucinate trajectories, new state, 0 actions, 240 eval. This. D state a prep. Yes, this is fine. And then you either use, if it's a terminal, you get real observations, otherwise you get hallucinated observations. Real observations you get encoder, otherwise you get dynamics, yeah? We sample logits. We detach H and Z so that the gradient cannot go from the actor to the world model. This made a huge difference in stability. Reward terminal logit and value. Whoops. Terminal and reward are already trained. Supervised, the only thing we need to train is logit and value. Dynamics and a representation loss. Decode. Yeah, the decoder is the yeah, there is a decoder loss. It's the reconstruction loss right here. You do self policy, you reconstruct. You have a full reconstruction loss mean squared error. And then they do this wonky thing where they try to make the encoder and the dynamics match each other, and they do two different KL losses. Bullshit thing. My head hurts? Yeah, exactly. I do not like this paper. Yeah, well, what do you do instead of mean squared error on an arbitrary reconstruction loss, though, right? They have it written as a log, but I checked one of the implementations, and, like, if you tab through 5 layers of horseshit, it's like they've literally written a mean squared error and then just named the variable log. So I probably should go to the original code even though it's a mess, because there could be really important discrepancies. I mean, dude, what do you do on, like, arbitrary obs? Like, you can't like, there's no, like, cross entropy loss or KL or anything you can write on that, right? I mean, this is, like, reasonably kind of okay, I guess. Is there a fast version of this we can make work? I mean, I guess, like, so much freaking compute on cart pole. I think pretty much all of them. You see on the top right. I've tried, like, 10xing the reconstruction loss. I haven't tried on breakout, though. Maybe I should just do more of this crap on breakout. I mean, but, like, that's because they're clipped, that guy. So anything that is below 0.2 gets clamped to 0.2. I suppose I could do it in line instead. I'll try removing the clamp here. If removing the clamp fixes this, like, yeah, they can go fuck themselves, because this was in the paper. It's weird because, like, basically this means that these functions just don't get trained at all. No, it's not. It's the opposite, that guy. It's that when they're that high, they literally do not get trained. So it's the opposite of that. And now, like, they are getting trained now, I suppose. Hard to say if this is better yet. It has to stay above 7, like, stay consistently above 7 for it to be above random perf. Or above, like, trivial perf, rather. I mean, I could do this and 10x the reconstruction loss, I guess. Oh, the freaking zero entropy. You see that? Zero entropy on the policy. Yeah, I'd like to sweep the losses, but, like, I literally, with all the manual fiddling, I haven't gotten anything to be above random perf. Like, you need some sort of starting point, right, before you can really sweep. It gets zero entropy as well, and it'll do that often on some, like, on ends, even with a huge entropy coefficient. Is ridiculous. I don't even know how it does that either. I mean, it can't train now, right? I mean, I guess theoretically it could regain the entropy. But it's not like everything's nanned out or something. It's just like full on entropy crashed. And I've not ever found an explanation as to why. The entropy does come back, oddly enough. I think what else I can mess with? It could just be the reconstruction loss being like too low scaled. This thing is not going anywhere. I could do this type of a thing. You're not gonna do it. Watch this for too long. No, I kind of want to just get cart poll stable with more fresh data. Because this, like, this thing is ridiculous the way it is. Fine. Like, that could literally be random. The reconstruction loss is appropriately lower at the very least. Like, I 10x the loss coefficient and it optimizes better. I mean, at least that is as expected. Right, so there's like high data regime cart poll. Not fully solving. Do star the repo. Thank you very much for the advertising here, Bet. Folks, do star the repo. It helps me out a ton. It's free. Back to high data regime. We know that we can go lower data regime with the way that this algorithm is set up, right? $150 without the clamps. I clamp to 0.2. Happens if I clamp. Alright, so I mean, this clamp just seems bad. To me, at least. At least now we have a fast way to play with this. Construction loss. Okay, 10xing reconstruction loss, terrible. Let's make sure I didn't break anything. Fine. Being consistent, right? No, I mean, it's like 130. It's close enough to what it was before. What about the world model loss? Just the relative balance. Okay, I mean, but this doesn't make the huge difference, right? About do this. Okay. I don't think I can get away with putting this too much higher. But I do think that you're supposed to train the world model more the RL policy. Yeah, it's gonna get more and more unstable, I think. Okay. And honestly, it's not even like this huge difference either. I don't think it's just the balance, at least. I mean, it's also like, do we honestly expect this to do as well as quickly? Kind of. What happens if I do 8 update epochs? Okay. I mean, that scales well. It's just, is it stable? It's like not fully stable, right? Do we see anything with the rewards being wonky? Like, yeah, look at this. Well, what is this here happening? What the heck? No version of this stupid thing is stable. Right? If it's the value loss moving. If I just do this. Just do anything. Collapse down again. Not what we're doing. Looks like it. Trippy is quite a big loss. Could not run CUDA on a fresh install. Yeah, so what happens there is you need CUDA dev. You probably just have CUDA runtime, and you need like CUDA dev, the CUDA dev build. And the reason for that is that we have a custom CUDA kernel that needs to be compiled. You just need a CUDA compiler, right? You need NVCC. If you have NVCC, it should work. See what happens with this. See how long this is stable. Well, good things can't last. It like unoptimizes itself. Ridiculous. Ridiculous. Can't figure out how to re-optimize itself either, which is even worse. Sure, this isn't gonna help, but what else do we do? I'm kind of out of ideas. I've checked this pretty thoroughly. I don't think we've seen a single thing that's made this stable this entire time. Not fully, at least. What happens if I make the replay smaller? I mean, like, maybe a little worse, but, like... not by much, if so. I mean, we've seen that this definitely is not just a pure function of the replay buffer as well, right? What is there left to even do? I'm sure this isn't anything, but I'm out of ideas. like slowly optimizing down. Optimizes up, optimizes down, right? How? Like literally how? Let me see if there's anything from that Reddit post. This I have. Scalars. 2hot plus Simlog decoding mandatory. Needs clamping. Max 0 and KL -1. KL collapse needs clamping. Imagination drift. Hot plus Simlog decoding mandatory. Don't believe that. I tested that extensively. Wait, hang on. Simlog plus was it 6? Yeah, it's already 6. I'm working on this all day. Crazy. I have this. Well, I gotta go get dinner. We've made some progress, I suppose, today. It's brutal, though. It's absolutely brutal. If anybody else has any ideas on like what is actually required to get this thing consistent and stable, please let me know. It's like in the pretty much latest thing is in like OnPol world model, OnPol WM branch of the GitHub. For the folks who've been watching all day or watching for the past few days of this like nightmare thing, this is just how research goes. All the literature's a mess. All the reference code is a mess. I'm gonna have to start like looking through the actual original code, even though that one's even worse. And I'm gonna go from there. If you're interested in my work generally, Puffer.ai for all the things. Try the repo. It's free. Helps me out a lot. Go in Discord if you want to get involved. And other than that, you can follow me on X for more RL content, including a bunch of articles you can't find anywhere else. I am going to keep working on this at least for a decent while because we need some version of an algorithm that lets you scale more data or more compute instead of more data. This is the most promising candidate. There are adjacent pieces of work that are similar and even more complicated to implement. I don't think anybody really knows what the hell they're doing in this space, frankly, because I know for a fact all the code bases are a total mess and none of the experiments are controlled. And we're going to change that. But it's going to take a while. And I'm hungry, so I'm getting dinner.